Hello. In this episode of our Morrison Tech CAD tutorials, I want to talk about derived components in Autodesk Inventor 2021. So the first thing, you may not know what a derived component is. A derived component is something you can use in your assembly modeling to use geometry from another component to create geometry in a new component. So for example, I've got this hairdryer design on the screen here. If you look at this hairdryer design, there's two halves of it, and to a point there are just mirrors of each other, but there's also things in them that aren't necessarily a copy from the other one. So if I turn it off, you can see there's a groove in this one. So we're starting to put in an interlock feature. So the other half cannot have that groove. It's got the opposite feature in it. It's got the tongue feature in that section or in that area. Okay, so at one point these were the same part, and then at some point we've put in some features that make them not mirrors anymore. So what I can do with derived components is I can model the part up to a certain point. At that point being when they stop being identical mirrors of each other, and then I can make new components and link that geometry into it, and then start modeling the features for each half in their own files. And so if I look at my assembly structure here, before we get into how it works, you can see I've got this third component up here that says Hairdryer Master. Okay, so if I go to that part file, what it is the original model for the hairdryer housing without any of the details for the interlock or the cutout for where the switch goes or anything that wasn't going to be in both halves that's the same. So this is the master model of this hairdryer assembly. So I started the model in this one, and then when I made my assembly, I made pieces for the right and the left half. And then I did what I was talking about with the derived component to make the left and right half using the geometry from that master model. So what does that mean? Well, one, I didn't have to do a lot of work to make the left and the right half. I didn't have to copy what I did to make this shape. But what it really does is means that this master model, this hairdryer housing, is going to control the shape of the rest of the components that are derived from it in some way. So if I just do something simple here, and let's change this extrusion of the blower end of it, and we'll just make it really short so you can see what it does when it updates. So I changed that guy, made it really stubby looking now. But the power behind this is now, if I go back to my assembly, you can see by my components over here, they got little lightning bolts next to them. So if you go into the Manage tab and hit Update, it'll update my assembly, and now my two halves match the master model again. Okay. So if I go to the left half and the right half file, they update. Now, for some reason, I lost my material when that happened, which is a pretty minor thing. We could work around that, but you can see what it does for you. So I just changed one half or one file, and both halves updated. The shapes are the same. You can see that the interlock stuff that I had drawn in there, those details are still in there, even though I've got, like I said, a material problem for some reason. Let's try a different material and see if it fixes it. Yeah. All right. So anyway, you can see that the details are still there. Everything still worked. Nothing broke on that model when I updated it, which is a whole nother story. But you can see how that master model controls the shape of all the parts that were derived from it. So what I want to show you how to do is how to set that up and get that to work on a part like this. And you guys can probably find more ways to use it than what I'm going to show you here. and maybe it'll be a very useful tool for you when you're working with some assembly models like this. All right, so now let's work on how I set all that up and got everything working on it. So here we're looking at the master model for the hairdryer design. This is the part that just has the features and details that both halves are going to have in it. Both sides, both mirrored pieces are going to have this exact shape. So we don't need any extra details in here. We're going to put those in those actual halves. Okay, so the next step is going to be to make an assembly file. So I've got an assembly here that's got no components in it right now. So I'm going to add new component. I'm going to add the one called hairdryer. That's my master model. I'm going to place this grounded at the origin and then get out of that. So I've also already started 2 files for the right and left half. You can see those are also empty at the moment. So those are just brand new files. I'm going to bring those into the assembly. So I'll bring in the left half, place it grounded at the origin also, and then bring in the right half and place it grounded at the origin also. So you can see now I got my assembly now structure over here that's got the master model, the left half, and the right half. All right, so the next step is going to be to go ahead and do some of that linking I talked about using the derived command. So I'm going to start with the left half. And in the left half, what we're going to do is come into the actual model file for it, model tab, go to manage, and under this area in the middle of here, there's this spot that says insert, and there's a derive button. So we're going to click derive. It asks you what file or what part do you want to derive geometry from. So I'm going to derive from the hairdryer. Hit open. And when you get to the next step, it shows you the hairdryer. Notice I'm still in the left half file down here, but it's showing me that model that I have created in the other half, or in the other file in the master model. So at the top of here, it's got a Derived Style button or section where you can change how you're deriving the geometry. There's a single solid body merging seams between planar faces. There's a solid body that keeps seam between planar faces. Those are going to be when you have multiple solids into a file. Just not exactly what we have going on here. So we're going to use the last one that says maintain each solid as its own solid body. And like I said, we only have one solid object in this, so that's going to be the best option for us. There's another one that says use solid body as a work surface. That one I'm not exactly sure what it does, but you might be able to find a use for it. Down below, there's a section where it shows the different types of things that you can derive from this. So if you hit the plus button on the folder for solid bodies, you can see that there's only one solid in there. So these are kind of like on and off toggles with a little plus, yellow pluses, or means that we're linking that, or we're going to bring that in, derive it. If I turn it off, it goes away. So you can see I can also derive sketches. So I can bring in certain sketches or all the sketches from that file. Okay, so this one's going to be important later. Work geometry are going to be your work planes, so you can bring those in. And then parameters, there's a set for model parameters, and that's where all the values that I've used for extrude dimensions or revolves or whatever I did in that part file where I typed in a number to create something, that's what the parameter section is going to give you. All right, so for now, we just want that solid body. And we're going to hit OK and create it. So now you can see in your model tree over here, there's a model feature that says hairdryer IPT. So what that is a derived geometry that we've gotten. So if I right click on that, I can go to edit derived part and get back to that dialog box that we just had up. So I can change what is shown here. So if I need a sketch, I can turn that back on. Okay, so you have the ability to edit what you can see from that derived component. All right, so in order to keep this a little bit less confusing as to what we're looking at, I'm going to give this one a property of something that's got a little bit of color to it for now, so we can tell which half is which. All right, so that's the left half. Now, if we go back to our assembly, we should see the left half, which is right over top of the master model. So we can turn the visibility on the master model off for now and see that we've got the left half, and it's going to be located in the proper place because we've grounded all three of them at the origin. So I cannot move it around in the assembly. All right, so let's do the right half real quick. Same thing, we're going to go to Manage and Derive, pick the Hairdryer file again. This time we're going to do something a little different. We don't want that model exactly the way it is. We need it mirrored. So there is an option down here. It says Mirror Part. And then you get to pick the mirror plane. And that's the XZ plane for this part. And everything else is the same. I could do sketches and stuff if I wanted to also. But I just want the solid. And there's the right half. So again, go back to our assembly. You can see now I have a model for both halves. Okay. So that is a quick way to draw both halves and get them their own model. So the next step is going to be to start putting some features in that are not mirrored in each part. But we're also going to use those features to create the geometry in the other half. So like I said, sometimes we're going to draw things like that interlocking groove I've got on here that we need to be able to reference the geometry from one file, but it's not going to be the exact same geometry in both files. So I will show you how to get that set up next. All right, so the next step is to go ahead and start putting in some of those details that aren't mirrored exactly between both halves of this hairdryer piece. So what we're going to do is going to go into the right half real quick, and I'm going to start a sketch down here on this end, and I'm going to draw in the groove section, or the tongue section, sorry, of the interlock that we're going to build. I'm not going to get real carried away with constraining it. So let's just say that's good enough. Finish sketch, and then we're going to sweep that. Along that edge and join it. And so we've got our interlock feature. So once again, you'll notice, like, I go back to the hairdryer, the original master model, that's not on there. Go to the left half, nothing there. All right, so what I want to do is I'm going to derive again and link that sketch that I just used to create that piece so I can make a sketch that is offset from it in the left half. So one thing you have to do before you go ahead and go to that other file and do the derive command again is you need to make your sketch that you're trying to derive, make it visible. For whatever reason, it won't show up if it's not visible. All right, so if we go to left half, and we'll go to insert and go to derive up here. I want to derive the right half this time instead of the master model. And when I get in here, I don't want the solid. I just want the sketch. So you can see down here on the end, there's the sketch. Okay, so I'm going to leave that the way it is and hit OK. And now I have that sketch that shows up. So what I can do next is start another sketch in this file on that plane. And I would draw my feature I want to cut out of there. And then I would constrain it to the derived sketch. So I've got to project it. Then I can dimension some things. I'll just throw some constraints out here real quick so you get the idea. This isn't exactly how I would do it, but you would constrain this how you needed it to be. All right, you get the idea. So finish sketch. Then I'm going to go back and sweep this. And this time I'm going to cut that out. And hit OK. And you can see I've got the groove section. Not as well defined as the one in my first example, but you get the idea. Okay. So that's derived from the other half. Now, again, if I've got some other features that I want to put in there, let's say I want to put in the hole for the switch here, and I want that in both halves. I could have put that into the master model, but what would have happened is when I went to do this tongue and groove for the interlock, there would have been a broken spot in it, so I couldn't put it in at that point. So I've got to do it at a different point in the model. So I've got to do it in both halves. The nice thing is, though, I can do the derived trick again to link the sketch between both halves. So I'm going to start a sketch again, and I'm just going to pick that plane since it's in the right orientation. Draw a rectangle out here. And really the only constraint I want to put in is the width and center it on the two parts. All right, so I want to dimension it from that plane down. I'll make it D5 divided by 2. And then I'm just going to drag it down here a little ways so it's in the right spot. I'm not going to put any length dimensions on it. You can figure out how to do that, I'm sure. All right, so we're going to finish that. Extrude it. Cut it out. Hit OK. Again, we'll go back and find that sketch, show it, or make it visible. Wrong CAD package. Go back to the left half, and then I'm going to edit the right half derived feature. Oops, I shouldn't have done that. Don't double click on it because it sends you back to the file for that where the derived comes from. So I'm going to go and right click on it, hit edit derived part. Go to my sketches. Now there's another sketch on there, so I'm going to add that sketch also and hit OK. And so you can see now in the left half I've got that sketch also. I can extrude it, subtract it, and you can see I'm starting to get some details on this part. Okay, so anytime you want to derive something between the two halves, so you can either use it directly like we just did for that hole, or you can use it to constrain some more features, more sketches that you've got to draw in this half so that they're related to each other. You can use the derive command to do that. And then just like I showed you with the master model, if I come over here and go ahead and edit this sketch, since I don't have any constraints, I can just kind of drag it around, make it shorter and wider. Finish the sketch. Now if I go back to the left half, you'll see there's a little lightning bolt in front of the right half derived feature. So all I've got to do is go over here to manage and hit update. And hit the update button, and the sketch updated. Now you can see my groove matches the shape and the constraints that I put on my sketch in this file. So it's all updated and it fits together nicely. Go back to our assembly. Some of the stuff in the assembly gets a little bit messy. The derived features kind of show up visible as long as they're visible in the part file. So you do have to go through and clean that up if you don't want to see that stuff in the assembly. At some point, it may start to bother you. That's just something that you might have to worry about later. Okay, so hopefully that explains what you can do with derived components, though. So if you got any questions or want to see some more on this or other applications, hit us up in the comments section down below and we'll see what we can do about that. And thanks for watching.